Okay, all right, so what in front of you, I have the major cities map. In fact, I'm gonna hand those back to you. I know that you had copies of these yesterday. The reason why I gave you copies of these is because sometimes it's just nice to know where the city's at. So you can look at, I only picked major cities for the assignment today. You are gonna get a worksheet today. It's not gonna be in your textbook, so you didn't need your textbook. It's just nice to know if the major cities, where they're at, so you don't need to look them up at all moments. Okay. All right. Okay. Are we good? Okay. We can pick any city. So now there's going to be two types of problems today. The first type of problem you're going to have, the city will either be directly east and west or directly north and south of each other. That's the first type of problem you're going to have. I believe there's only one that won't be. So I'm just going to pick two cities real quick that are just north and south of each other. I'm going to pick Kansas City and Fort Smith. Those two are directly north and south. We'll do one example of this just so you can see the ease of what you need to do and how you need to identify it. Then we're going to pick a different problem, and we'll pick one that is diagonal from each other. Okay, any type of diagonal, I'll just pick two. When you do a diagonal, there is way more work that needs to be done. And I'm talking a lot more work. So, make sure you have out your notes. You're going to want to take a bunch today so that you can see it. Does everyone understand what we're going to be doing here? Okay, if you have a Chromebook, it'd be a really smart idea to have it on the desk next to you, opened up to Google, because I'm going to need coordinates for cities. Okay, so let's start with the first one. What we're going to do, and the goal is here to find distance on a map, but you need the coordinates for it. So distance, I need Kansas City. So Kansas City, I need that. I need the coordinates for Kansas City, so the latitude and longitude of it. And then the other town I need is Fort Smith. So these are the two towns. Fort Smith, I believe, is right on the border of Oklahoma and Arkansas. And then Kansas City is on the border of Kansas and Missouri. So if you don't know where that's at, I have it drawn up there if you can see it. I need the coordinates though. So if somebody wants to research Kansas, somebody wants to do Fort Smith, I need to know the latitude and longitude, east, west, north, south number, whatever that is. It's going to be north and west. That's what these are going to both be. So if somebody gets one, fire away. What do you have? Please.
The coordinates for Fort Smith
Okay.
is 35.3859.
And that's degrees north. Okay. And west?
94.3985.
85 degrees west. Okay, perfect, thank you. Okay, did somebody do Kansas City?
39.11.
I can't hear you, sorry.
39.11.
39.11.
55.
55 degrees north.
Yep. And then 94.6268.
68 degrees west. All right, now, here's what I want you to identify when you first start this problem. Which numbers match? Which numbers match on this one when you look at both coordinates? Do we agree that 94s are basically the same number? Okay, since the 94s match, we don't need to worry about those. If they were significantly different, you'd have to find the distance between those. I'm not finding those, so I'm going to leave those alone. I'm going to find the difference between the 39, 1,155 10,000s, and the 35.3895. I'm going to find the difference between this. This is my angle I need to find. This is that theta in my formula that we're going to be using here in a second. So, what do you get when you subtract these numbers from each other? It's going to be a small, it's like 4 degrees or something like that.
13.726.
Oh, it should be 13. 39 minus 35.
3.726.
3.726? Okay, and that's degrees. Okay, that's the difference. So it's about 3 degrees off from each other. The other one, there was like no difference. It was 94 and 94. There's hardly a difference there. It's negligible. I can ignore it. But this is 3 degrees off. 3 degrees on a planet is really big in terms of surface distance, 3 degrees. 360 is all the way around the planet. So 3 degrees is a pretty good distance around the planet. And so what you're going to do, this is the formula that I'm going to use on every single problem today. S equals r theta. Okay? We're going to be multiplying the radius of the Earth times my angle. So, in my case, the radius of the Earth is 3,958.8 miles. I believe that's what you guys figured out yesterday. You're going to use that number every single time today. So that's my radius of my Earth. That's my r. And then my angle is that difference that you just found. So that's the 3.726 times pi divided by 180. And that's the little thing that you need to do today. You're going to multiply these out, and what this will tell you is it will tell you miles. Because S stands for arc length. It's the distance along a curved path, a circular path, a spherical path. So 3958.8 times 3.726 times pi divided by 180. And what do we get? Multiply that times pi divided by 180.
The coordinates on Fort Smith, I said it was 5'9".
Not 9.5?
No.
5.9? That's fine. We'll go with it. So it was 5.9, not 9.5. Yeah, we'll leave it for right now. That's not a big of a deal. It's 5.9, not 9.5. All right. That's fine. We'll leave it for right now. We'll just assume this is correct. Okay, what do we get? We multiply all those numbers out.
257, 42.
0.42?
Repeating, but the
42, 42, 42, 42. Okay. All right, so 257 miles. Does that make sense what we just did? You multiplied your radius times your angle that we found times pi divided by 180 because we're on a circle, so you have to put that in consideration. All right, now, here's the next thing you have to do. Now that you found the distance, this is the answer. This is what we wanted to find. Now, I'm also going to ask that you go on Google. You go on Google and you find what the actual distance is on Google. Okay? So, go research Kansas City to Fort Smith in terms of distance driving. Or, you can just have in Google distance from Kansas City to Fort Smith and hit enter, and it'll probably tell you in the first 2 searches on Google what the distance is. So this is what my formula tells me. What did Google say?
290.7.
290.7 miles? Okay, that's our first reasonable problem so far. The reason why is it's typically Google will always tell you a number that's bigger than it is. The reason why is it's a driving distance. You're going on curved paths, so you're driving a longer distance than what the actual straight shot is. So that's actually our first number that makes total sense to me now. The last couple of days we haven't been getting realistic numbers. All right, questions with what you're going to be expected to do on like 3 out of the 4 problems. You have 4 problems in your homework, I believe. Okay. All right. Now, the last one. This will take us about 10 minutes to walk through today. The last one is insanely difficult. So, I shouldn't say insanely difficult. It is a lot more work. Maybe that's the better way to put it. It's a lot more work. In fact, you'll need a calculator. So, does anyone need a calculator in here? Everyone's got one? Anyone need one? Okay, you need one? Okay. Okay, it's going to be one of those things that you're going to want to take notes on this next one. This next one, like, yeah, this is the same stuff we've done, what, 3 or 4 times now in the last couple days? So that one shouldn't seem too bad. This next one's way different. So, all right, Oh, perfect. Okay. All right, so let's talk about our last example of the day, and this will be like the last problem on your worksheet. So, and you'll see why this is going to be very, 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 very difficult and very different. Okay. All right, so again, you'll need your Chromebooks so we can research the different towns. Okay. Welcome back, Mr. Rampel. Okay, so let's walk through the last type of problem here. We're going to go diagonal. I'm just going to pick two cities that are kind of diagonal from each other. Let's go with Dallas, Texas. Dallas, and let's go with Cleveland, Ohio. Cleveland, Ohio. That looks like a pretty good distance, and we're diagonal from each other. This is a very, very, very different problem. All right, so Dallas, Texas. To Cleveland, Ohio. Okay, I need the coordinates for each of these. Same, it looks almost the same work. You'll see why it's not. All right, which one do we got? What do you got there, Miss Brown?
Dallas.
Dallas, what do you got?
32.7767.
67 degrees north.
And 96.7970.
70 degrees west. Okay, good. Somebody else have Cleveland, Ohio.
41.4993.
93 degrees.
81.6944.
69.44 degrees west. Okay. Both numbers are off. Not your numbers you gave me are good. I'm saying that the north and south numbers are different, and the east-west numbers are different from each other. So it's not just, oh, I noticed that, these match, so I can ignore them. No, we're off on both. The north numbers are different, the west numbers are different. So we have to do math for both numbers. Now, here's what I'm going to try to explain to you. I'm hoping this will make sense. I want to do the north numbers first, just those two. The difference in north to south. Okay, and we're going to do it the same way we just did. We're going to subtract them, plug them in my formula, and find that number. That number is going to represent this on my graph. It'll represent this north distance. Yes, we are. That's exactly what we're going to do. That's why it's way more difficult. Okay, does that make sense what I'm about to find, that north distance? Okay, so what do we get when we subtract those two numbers? The 41 and the 32, what do we get?
I got 8.7226.
Okay, 8.7226 degrees off, okay? That's the difference between the north numbers. I agree with buddy, okay? All right, now, we're gonna plug them into my formula. So we're gonna do all the same math. So I'm taking and I'm gonna plug in, my radius of my Earth, we're using the 3,958.8 miles, so you guys have been telling me the last couple days. We're gonna take that times my angle, times pi divided by 180. And I need to know what that distance is. It's probably a ways. I'm expecting it to be 400 or 500 miles maybe in that ballpark, just estimating in my head, just looking at this distance. Longer than 200 that we just got in the last one. I'm saying about 500.
I got 602.68.
602 point what?
68.
Okay, miles. Say it again. Was there a question?
Oh no, I figured out where my pi was.
Oh, good. Yeah, so 3.5 or 3,958.8 times the 8.7226 times pi divided by 180, and boom, it spits out your number. Boom, that's it. All right, now on my graph, here's that number. That is this number, 602.68, and that's miles. Okay, that's that north-south number. I'm not done yet. That isn't the distance between my towns. That's just the difference in north to south between the cities. I now need to do the difference in east to west. This number now. I need to go the west distance. So we're going to do the same thing now, the exact same math, but we have to do it for west now. So we're going to start all the way over and find my new angle now. My new angle is between the west's two numbers. This looks like it's to be about 15.
We're at 15.09.
15 point what? 09 degrees. Yeah, quite a difference in those numbers. So again, if you subtract them, you can figure it out. So 15.09 in degrees. So I'm going to plug these numbers into my formula. My formula is this. It's the 3,958.8 miles times my angle, 15.09, times pi divided by 180. This will give me my mileage. What do we get? 3,958.8 times 15.09 times pi divided by 180. What do we get?
1,032.
Say again?
1,032.
1,032, and is there any decimals?
42.
0.42?
1,042.
Oh.
0.63.
0.60. Wow, I was way off. Okay, that's my bad hearing. All right, 1,042.63 miles. Okay, now that number on this graph is this thing. This is the 1,042.63 miles. So I think you have to do this on your last one out of the 4. So you have to find those distances. Okay, are we good so far? If you notice, it's the same math. You just had to do it twice. So it's like 2 problems in 1. We're not doing it yet. This is where you probably need the back page of your worksheet. Okay, I'm going to get rid of the picture now on the marker board. Are you guys cool with that?
Yeah.
I'm going to leave that triangle on the board though, because I think it's important we see that. All right. This is what I want you to see. This is like on the back page of that worksheet. This is what I would draw. I would draw a triangle with those numbers and those locations. This is supposed to be a right triangle. So if you didn't hear Mr. Brown earlier, he was absolutely right. He goes, oh my goodness, we're finding the hypotenuse on a right triangle. And he's right. This is a right triangle. These are called the legs of your triangle. That's a leg, and this is a leg. And the long side, the one that is diagonal, that wall is called the hypotenuse. Now, Brandon, do you remember how do we find hypotenuse?
Is that a squared plus b squared plus c squared?
Yes. A squared plus b squared equals c squared.
Yep.
It's the Pythagorean Theorem. If you've never heard that, Pythagorean Theorem is one of the most famous theorems in mathematics. It's used in a lot of stuff. Well, you're seeing Google use it for the first time. So, what your a squared and b squared are, these are your legs. You have to square the numbers. Now, if you don't know what a square means, you can take the number times itself. And then your hypotenuse is squared. And this would be the wall you're trying to find. This is the hypotenuse squared. So, what is one of my leg numbers?
602.
Okay, yeah, 602.68. We have to square that number. You have to take it times itself. You get a really big number. It's like 36,000 or something like that. And then you're going to take the other leg, which is the 1,042.63. You're going to square that leg. So you're going to take that times itself. So now you're probably in the 100,000s. And then you're going to set this equal to the wall I'm trying to find, the hypotenuse squared. Now, what I need to know, when you square these numbers, because you should have a square button in your calculator, take this number, put it power 2, you have a little square. It's right here, by the way. A little square key on my calculator is right there. You can square a number really quick, type it in, hit the little square key, and I'll square it for you. I need to know what those numbers squared add up to be. This number squared, add up. You add them together. This is a very, very large number.
1,450,300.
50,300?
Yep.
Is 8.2?
Yep.
Okay. All right. So we squared that, we add them together, and that's the number we got, right? Okay. So this number plus this number, whatever it is, made that big number. Big number. Agreed? Last step to solve. This is my final answer, by the way. Final answer. You have to get the hypotenuse by itself, correct? That's the whole point. Get the hypotenuse. Get this weird diagonal wall. That's what they call a hypotenuse. You have to take this 2 to the other side and do a square root key. So if you don't know what a square root key on your calculator, on my calculator, it's actually right here. It's in blue. So I think for the green calculator, it's probably in green or white. I think you have a square root key on that calculator, Ms. Brown. I think it's right in maybe the top row. You have a square root button. Looks like a little square root key. Maybe in the top row, maybe. I don't know. But you're going to hit the little square key and type in your million into it. Let me come back there and take a look. Take a look at your square key. Type in your million. 1,450,000 whatever. Okay, I think your square button is right there. Type that in. Type your number 1,400. No. And you got a square root. Oh, wait, what? Okay, say it again.
1,204.284.
1,204.284. Is that what you said? Is that what everyone's getting? Okay, that's your distance between the cities. Now, if you check Google, type it in Google, you'll figure it out. It's pretty close, actually. 1,300.
1,300 miles.
Yeah. The last one actually turned out pretty reasonable. We were actually we overshot it on the Google search, which is normal. But if you actually search distance between Cleveland and Dallas, it should be around that. Every problem I want you to do the normal math. This is the tough problem at the very end. I'm going to leave this problem on the board today. You have to do it twice. The north, south, east, west, and then you have to put it into that triangle and do the Pythagorean Theorem to it. That's not normal. You normally don't do that. But because my towns are diagonal from each other, that's why you have to do it. If they're directly north and south, you don't have to do this. If they're east, west of each other, you don't have to do this. It's when they go diagonal, you have to. It's a lot of work. Google does it automatically and it makes it look simple. That's a lot of work. It's calculated in a few seconds. So it's pretty good about accurately telling you numbers. Okay, all right, but that's it for today. I'm going to turn you loose on homework here. You have a worksheet. This is due on Tuesday next week. Due on Tuesday. Grant, welcome back. Feeling okay? Yeah, I can only imagine, but.
I'm gonna refresh them.